Hello, I'm Dr. Sanjay Gaikwad. Welcome you in the lecture series. Today we are going to talk on the subject pH meter. We know that there are so many type of compounds are there, and the chemist feel that what is the pH. In this topic we are going to discuss what is pH meter, glass electrode, combined glass electrode, standard buffer solutions used for the reference, then accuracy of the pH meter, and how this instrument it works, and applications of the pH meter. Now, this is the basic fundamental instrument where we are measuring the concentration of hydrogen ion present in the solution. pH meter is an electronic device, electronic instrument used for measuring the acidity or alkalinity of the liquid. It consists of measuring probe like glass electrode and reference electrode connected to display the pH reading. Now we observed in our life or in our daily life in the laboratory as well as in the house the variety of the pH. Now in case of the lithium battery, we observed that the pH of the material used in the lithium battery, it shows the 0 pH. It is a very strong acidic in nature. In our gastric or stomach, the gastric acid is there and it shows the pH 1. In lemon, it shows the pH 2. In apple juice, pH 3. In tomato juice, it is a pH 4. Black coffee shows the pH 5. The pH of the milk is 6. The pH of pure water is 7. The pH of the egg 8. Baking soda 9. Hand soap or hand wash 10 pH. Ammonia solution 11 pH. And bleaching solution and higher alkali shows the higher pH than 12. Now for measurement of the pH, we are using the pH meter. Now this is one of the instrument pH meter. By using this instrument, when the electrode is dipped into the solution, immediately we can measure the concentration of hydrogen ion in terms of the pH. Where we are using the glass electrode, and nowadays this type of pH meter is also used, and as well as this is the pH pen, this is a pocket pH meter. In this pocket pH meter, the glass electrode is dipped into the solution, and directly after standardization we observe the reading as in the form of the pH in 0.1 measurement or least count. And by using this pH meter, we can measure the 0.001 up to this level, we can measure the pH. For pH meter, we are using the glass electrode, simple glass electrode, as well as the combined glass electrode containing glass electrode and calomel electrode as a reference electrode. And we observe that we can represent this reaction as glass electrode, reference solution, test solution, and glass electrode. A glass electrode is a type of ion selective electrode made up of doped glass membrane that is sensitive to the specific ion. The most common application of ion selective glass electrode is for measurement of the pH, and the pH electrode is an example of the glass electrode. Now this glass electrode having the thin glass bulb with a special quality and containing a fixed concentration of 0.1 molar HCl solution, and where the silver chloride wire is inserted in this electrode or glass bulb. When the glass electrode is immersed into the solution, the potential difference developed between the solution in the glass bulb and sample solution, the potential difference E is formulated by the Nernst equation, and we can observe that the potential difference in terms of the concentration of hydrogen ion, because the potential difference is developed because of the how many hydrogen ions are present in the solution. In the same way, that number of hydrogen ions are collected at the glass bulb and we observe the potential difference. Now, when we are observing the mechanism of the glass electrode, then this is the silver chloride wire is dipped into the HCl solution, 0.1 molar HCl solution, and on this glass electrode the electrons are developed, and around this electron when we dipped and it is connected to the pH meter, then the hydrogen ions are collected towards this electron from the solution, as well as at the same time the hydrogen ions from the HCl solution are also collected at the wall of the electrode glass bulb, and then the potential difference is developed, and that potential difference we are measuring in terms of the concentration of hydrogen ion or pH. Now, when this electrode is connected to the reference electrode as a calomel electrode, where the silver chloride wire is dipped into the 0.1 molar KCl solution, and this electrode, when connected to the glass electrode, we found that it is a combined electrode. Now here, when we connected this electrode, then hydrogen ions are get collected at the wall, and we observe the potential difference. And when this combined with the calomel electrode, from this place, this is the junction where the test solution is connected to this electrode, and from this wall, the test solution, the hydrogen ions are get collected, and potential difference between these two electrodes, that is the pH of the solution. Now, higher will be the hydrogen ion concentration, then it will give the higher voltage, and then we observe the pH is a lower, and vice versa. When lower the hydrogen ions present in the solution, we observe the higher the pH value. That is the basic pH, and all these pH of the solution is calculated with the help of Nernst equation, and by forming the EMF potential difference between the reference electrode and glass electrode. Now, for standardization of the pH meter, we are taking some buffer solutions, and these buffer solutions we observed in the market as a standard buffer solutions, pH 7 or pH 4 or pH 1.68 or 10 pH. Normally what happens, the potassium hydrogen phthalate is a standard solution, standard compound in the laboratory, which shows the pH 4, and that 4 pH solution can be used as a standard solution for the observing the pH 4 shown by the pH meter. We know that the buffer solution is a solution able to maintain the hydrogen ion concentration with only minor change on a dilution or addition of the small amount of either strong acid or base. Now, for example, in case of the acidic buffer, it is a mixture of acetic acid and sodium acetate, that is a weak acid and its conjugate base. When acetic acid and sodium acetate dissolve in water, it gives the formation of the three types of ions, that is sodium ion, hydrogen ion and acetate ions. Now, in this acetate buffer, when we add a strong acid, that is a hydrogen ion, it readily react with the acetate ion to give the formation of the sodium acetic acid, and therefore get neutralized, and whatever the pH is highly reduced by the strong acid, but it gives the formation of weak acid, and therefore very minute change takes place or decreases the pH. Now, when we are using the basic buffer like a mixture of the sodium ammonium hydroxide and ammonium chloride, then when dissolve it into the water, then it gives the formation of ammonium ions, hydroxide ions and chloride ions. When the strong acid is added, then hydroxide ion readily react with the hydrogen to give the formation of water, and when the hydroxide ions are added, that is strong base is added, then it readily react with the ammonium ion to give the formation of the higher, slightly increase in the pH is observed. Therefore, sudden change or shock in the change in the pH by adding the strong acid and strong base, we can use the strong acidic buffer or basic buffer. Now, when we are observing the accuracy of the pH measurement, now we know that the plus or minus 0.01 is the good choice for the quality control or research environment by using the it's shown by the pH meter. Accuracy may be a point plus or minus 0.1 to the 0.001 pH. Within this range, we can see the accuracy of the pH meter. Now, when we are observing the applications of the pH meter, it is observed that it is a very most important technique to measure the concentration of hydrogen ion present in the solution. It may be for the buffer and other solutions. It is useful for determination of the concentration of the solution. Then to measure the pH of the biological fluids such as blood, urine, gastric acids and another medical applications. It maintains the pH of the reaction mixture. Then it determination of the alkalinity and acidity of the solution as well as for the soil and water from the drinking water or by using the any water analysis. It maintains the perfect and accurate pH level. It helps to several daily activities like keeping the milk or from the turning source. pH meters are employed for the number of reactions to check the concentration of hydrogen ion, and in the reaction mechanism it has a most important role to measure the pH, and from that pH we can understand what is the reaction mechanism, what type